In this lecture, we will be discussing study design. I will talk both about the goals we have and how the choice of study design will affect the conclusions we can make from the research. If we recall, there are several reasons or goals people may have in doing research. I will talk briefly about description, as this is important in particular areas of I/O, and then I will focus most of the time on the latter three of prediction, explanation, and making changes. We conduct descriptive research in order to understand a phenomenon. We want to describe in detail what a situation or construct is. Descriptive research is frequently used in I/O for job analysis, which is the systematic description of a job, such as the duties and responsibilities, and the requirements, such as knowledge and skills needed to do that job. Job analysis will be the topic of the next module, so I won't go into a lot of detail. But to give you a little sample, let's imagine we need to do a job analysis to gain a detailed picture of a job that a company needs to hire a person for. Perhaps this is a small company and it has grown to capacity and needs to hire another employee to take over some of the workload. We can use job incumbents. In order to do job analysis, we can use job incumbents as participants. These are the workers who currently fill those positions. But we could ask subject matter experts or bosses. We ask participants to answer questions about various facets of the job, such as job tasks, required skills, products produced, etc. We also might want to supplement these surveys with observations of workers in their job, particularly to get pieces of information like time allocation for each task. Depending on someone's memory, it's sometimes risky to rely on memory for this information because, as we know, memory is not perfect. So people may have biases in what they remember about how much time they spend doing different tasks. When the data collection is complete, a very detailed report is written up to describe the job and requisite knowledge, skills, and abilities to do that job. So, if we look at our other goals of research, we can look at the goals of, when we look at the goals of prediction, explanation, and making changes, we are interested in relational hypotheses, meaning that they're all trying to get at the idea that two or more variables are related in some way. For simplicity, we're going to stick to discussing two variables for now. Let's consider the types of relationships that we have. We have associations, which are simply that two variables are related. We don't know the direction of causality, or even if there is causality. We just know that the two variables are related. And I showed you previously how we represent this with a curved arrow, double-ended arrow. We also have causal relationships, or causation, when two variables are related in a causal way. One variable has a causal effect on the other, and the direction of influence is in one direction. The extent to which we want to say there's a causal relationship instead of just an associational relationship, affects our study design choice. Remember, our hypothesis statements included language that distinguished whether we want to test a causal or an associational relationship. So those associational hypotheses said things like predictor A is related to predictor B, or is associated with, or has a negative correlation or positive correlation with. Our causal hypotheses directly stated that one thing caused an effect on another. The hypothesis statement then guides our choice of study design. Before I move on to study designs, however, I want to talk briefly about terminology we use for variables in our hypotheses. I'm sure you've heard the terms independent and dependent variables. An independent variable, or IV, is one that is controlled by the experimenter, while a DV, or dependent variable, is one that is measured by the experimenter. It is the outcome of interest. Let's look at our self-control hypothesis. Emotional labor is our independent or predictor variable. When we do experimental research, as you will see, it is independent in the sense that we can manipulate it, and its value is not dependent upon the outcome or dependent variable. The DV, however, in this case, eating birthday cake, does have a value dependent upon the independent value. It changes when the independent variable level changes. As you will see, variables are not inherently independent or dependent variables. That is, one particular measure is not always going to be an independent variable, or always going to be a dependent variable. Rather, it's a function of the research design and what you do with the variables. For example, we had two hypotheses about self-control. Our other hypothesis looked at meditation practices and the effect that it had on emotional labor as the outcome. In that case, we had emotional labor on the other side of the diagram here, in the DV position. I want to point out that the terms predictor and criterion, or outcome, are sometimes used interchangeably with IV and DV. Predictor and outcome, however, are more general terms, and I tend to use the terms independent variable and dependent variable specifically for experimental research, and predictor and outcome or criterion for correlational research. Confounding variables, as we discussed in our previous lecture, are variables that affect our dependent variable or criterion variables that are not a part of what we are studying. Sometimes we know what potentially confounding variables are, and we can measure them and statistically control for them. Many times, we don't know what they are. So let's take an example, the Hawthorne studies that we discussed in the history portion of our lectures. They were studying the effect of light levels on performance. So they would make changes in the lighting and find outcomes that showed that performance improved with changes in the lighting. There was a confounding variable present, however, and this was the presence of researchers. By having a researcher present every time the light changed, it was hard to tell whether it was the presence of the researcher or whether the light was changing that affected production levels. A way to test whether this was influencing the outcome is to manipulate whether researchers are present independent of having changes in the lighting. We can do this by having a situation in which a researcher is present and not changing the lighting, and having other situations where there is a researcher present and there are changes in the lighting. We also can have conditions in which we have changes in the lighting without the researcher and changes in the lighting with the researcher. We will talk about experimental design here in just a moment, but we would randomly assign people to all of these conditions. So let's talk about basic study designs. There are three basic research strategies related to the purposes of finding relationships, explanations, and making changes. These are experimental research, quasi-experimental research, and correlational research designs. Just to clarify, these are not study designs that match up one-on-one to each of these reasons for doing research. Rather, these research designs are organized in terms of the most to least able to make causal inferences. I will go through each strategy briefly and then discuss methods we can use with these basic designs. The essential difference between all of these is the extent to which we have control over potentially confounding variables. As we just discussed, these are the factors that vary with our independent variables and can lead us to making the wrong conclusions about the relationships among our variables. In experimental research, we control one or more variables and keep everything else the same. We create conditions or levels of the variable we are interested in, and then randomly assign participants to these conditions. So our independent variables are often called factors. The different levels of factors, or the different conditions within that, are the value of the independent variables. So good experimental design rules out alternative explanations by having a control condition. We would have between subjects group that is a control group. Or if we were using a within subjects design, it may be a pretest or baseline condition. In the pure form, experimental research is mostly done in labs, since it is easier to control environmental factors. It's difficult in the real world to completely have things under your control. So it's hard to get organizations to do this in the field. So let's take an example. If we use our hypothesis of doing more emotional labor, we would word our hypothesis statement to say, doing more emotional labor will cause workers to have less dietary constraint. In order to test this, we would create different levels of our independent variable. We'll have to create some kind of manipulation to require workers in group 1 to experience emotional labor. This may be through an interaction with a customer. Whereas in group 2, we would not have that interaction. We might have a pleasant interaction or no interaction. As our dependent variable, we may place a chocolate cake in the break room and then have an observational measure of seeing how much each person eats. In order to make this a true experiment, we need to randomly assign workers or participants to our different groups, our independent variable levels. So each participant will be randomly assigned to either experiencing emotional labor or not experiencing emotional labor. In quasi-experimental research, we're able to manipulate the independent variable, just as we do with the experimental research. However, we are not able to randomly assign. Because of this, we have potential confounds, or what we call threats to internal validity. Now, this internal validity is different than the internal validity, or this is different than the internal reliability or the construct validities that we talked about in the measurement lecture. We use non-equivalent control groups in quasi-experimental research. Participants are not randomly assigned at the individual level to the experimental groups. We may use participants, say at a department level, in which we can randomly assign the department, but all of the people within that department receive the same condition. So this is not the same as randomly assigning individuals. And there still can be confounds. We need to be able to take into consideration other factors that may account for the results of our quasi-experimental research. So if we go back to our hypothesis, we may have the same hypothesis statement that doing more emotional labor will cause workers to have less dietary restraint. And our manipulation looks the same, as does our DV. However, the big difference is that there is no random assignment. So let's talk about correlational research. Correlational research measures variables as they naturally occur and examines the relationships among them. This is good for getting initial data that we might want to test later. It lets us know that there is a relationship between two or more variables. And then later we can do experimental research or quasi-experimental research to better understand those relationships. Correlational methods are very common in IO, as these tend to include a lot of the survey research that is conducted. So if we continue with our hypothesis about emotional labor and dietary restraint, we would have to reword our hypothesis statement to say something like this: doing more emotional labor is associated with less dietary constraint. Now we have our predictor, which is something that already occurs, and we just measure it as it occurs. In this case, we may ask questions about how often an employee engaged in emotional labor throughout a given day. So we may give them the survey at the end of a workday. And our outcome may still be looking at how much of a chocolate cake the employee ate during the day. In this case, we still put the chocolate cake there. So in a sense, it looks like we had an impact, but we just set up a situation in order to observe it. So with this research, there may be random selection, which is different than random assignment. This is how we choose who will participate in the study. We still have nothing that is manipulated, and we have no random assignment. So when we look at our research designs, we should be concerned with a few things. Two of these are internal and external validity. Internal validity is the degree to which results of the research are due to the variables being studied, as opposed to some other explanation. The goal of research is to rule out as many possible alternative hypotheses as possible. This is the extent to which we can make causal conclusions from our research. So does X cause Y? But we have threats to this internal validity. There are many threats to internal validity, but just to give you some idea of what these might include. We may have selection biases. This is a bias in sampling participants. If we allow people to sign up for a study or to choose to be in a study, there may be differences between the people who choose to be in the study and people who do not choose to be in the study. This bias is a selection bias. We also may have instrumentation problems or changes in the instrument or measure that we are using. We sometimes see this with longitudinal surveys, where a company or an organization does a survey and then wants to find out a year later if people have the same responses. But they didn't feel like the question quite asked what they wanted to, so they make a change to the question. Now it's difficult to compare the results of one question to another. We also have differences, perhaps, in mortality. This is the degree to which people drop out of a study. And if we have an experimental design where it's a longitudinal study, we may randomly assign people to condition. However, if one condition is more onerous or more difficult to be involved with, people may be more likely to drop out. So we can't tell if the results are a matter of the condition itself, the manipulation we included, or the differences in the people that are left. External validity is the degree to which we can generalize to a larger population or time. Generalizability is very important because without it, the findings can't be used in any other context. If we study stereotypes with the psychology subject pool, we may find differences than we would have found in an older adult population. So the results of our study from the subject pool may not generalize to the larger population. Therefore, we have low external validity. So if we come back to our basic study designs, and we look at the degree to which we can make causal inferences. Remember, our experimental designs are in our experimental designs, we are most able to make these inferences. If we're interested in establishing relationships or predicting outcomes, we may not need to know why they exist. We can select an employee based on good grades in school if it correlates with good job performance, even if we don't know what it is about getting good grades that is related to performance. It still predicts the outcome we're interested in. However, if we want to explain relationships, we need to do experimental or quasi-experimental research. Although we may be tempted to depend heavily on experimental research because it sounds like it's the best in that we can make good causal inferences, there are benefits of quasi-experimental research. In particular, it's usually done in the field, and they are more externally valid. Experimental studies tend to be sterile or take the real world out of the picture. So a balance of doing experimental and quasi-experimental research is useful. For the goal of making changes to affect outcomes, it is useful to understand the causal relationships. It may be fruitless to implement a change based on correlational understanding. You might spend a lot of time and a lot of money to make a change only to find out that it didn't do a thing, because perhaps the causality was reversed from what you had thought. However, by making a change or creating an intervention and then monitoring the outcomes, we can help determine whether there is a causal relationship, because the change, that intervention, in effect, is an experiment or quasi-experiment. The key is to keep systematic records and to evaluate the results of that change. I want to talk a little bit about summarizing a research field. We have two main methods of consolidating completed research. We can either do a literature review, which is a qualitative review of research that has been conducted, or we can do a meta-analysis, which is a quantitative way of combining research results. Advances in meta-analysis have allowed us to use a group of studies to test a new variable new variables that haven't been tested yet, if the group of studies that we have varies on that variable. So for example, if we're looking at a meta-analysis and some of the studies were conducted on students and some of them were conducted on working adults, we can look at the results and compare to see if perhaps in the student populations there was no effect, and in the working adults there was, or vice versa. Also, another example would be type of performance. When we talk about performance, we're going to talk about different types, and specifically task versus contextual performance. Task performance is how well you perform on the job duties or tasks that you're required to do. Whereas contextual performance is your interactions within the organization and whether you conduct yourself in a way that leads to a better environment for all workers. A meta-analysis can look at whether performance outcomes differ by the type of task. So if you have some of the studies that look at task performance and some that look at contextual performance, you may find a difference in those studies. In your team research project, 2 of the research papers are meta-analyses that tested additional factors. Roth et al., 1996, looks at the predictive validity of grades for job performance and looks at various subgroups of these studies. Some of them look at different levels of education for those grades, so whether it was an undergraduate college degree, a master's degree, or higher. Hertz and Donovan in 2000 published a meta-analysis of the predictive validity of the Big 5 personality traits. In this, they look at differences in type of performance, like I just discussed, task performance versus contextual performance. If you think about the operational definitions or measures you have chosen for your constructs, this may tell you how you will collect your data. The methods are part of the research design, but do not tell you what research strategy or basic study design is being used. I point this out particularly because surveys or questionnaires are used a lot in IO research. People often automatically think of surveys or questionnaires as being correlational research designs. This is often the case, but not always, and definitely not enough to use it as a heuristic. A survey can have some part of it, like the order of questions, manipulated to see if it changes how people respond to key items. So I'm going to discuss now different methods of collecting data, and I will briefly go through these different methods of measuring our constructs. With observational measures, this is a method that involves observing or recording ongoing behavior. Inter-rater agreement is very important with observational measures. As you can imagine, there might be potential observer biases. We can reduce some of these biases by making sure that raters are trained. They're given specific criteria and concrete examples. We want to make sure that the observers are not aware of the hypotheses. Otherwise, there might be biases in the results. And we also want to ensure accuracy of observations. This means that we need to record the observations in a timely manner. We can also have qualitative questions. Qualitative questioning can come in different forms in terms of interviews, open-ended questions, or focus groups. In this, we present open-ended questions and let participants tell about their experiences in their own words. In analyzing this data, we try to make sense of the experiences participants describe. We can use content analysis in which we count the number of times that people refer to a certain subject or a certain action. And we can search for these patterns within those responses. We can also use archival data, such as diaries, letters, medical reports, performance evaluations. We might use videos or electronic monitoring data, depending on the kinds of things that we're interested in. We can use survey methods or questionnaires, asking people to respond to questions about themselves or others. This is often done as a research design in itself, in which case it is correlational research. Or, like I discussed earlier, it can be used within another strategy. So surveys or questionnaires can be used within an experimental design to ask people about their experiences in the study. We often have two reasons for doing surveys. One is to get an assessment of population values or opinions. So for example, what percentage of the population uses computers in their work? We also might want to test relationships, like we've been discussing in our research methods. What predicts whether people will use alternative modes of transportation to get to work? We also have manipulations, which by definition, this is specific to the experimental and quasi-experimental designs. In this case, the researcher has control. In this case, the researcher has control over who gets what level of the construct of interest, such as being required to engage in emotional labor or not. So if only things were so simple, and we'd get a clear response for any hypothesis we tested. All studies would clearly fit into one of the categories I've created here. But that's just not the case. Studies are often a combination of correlational and experimental research. We can look at things like gender differences or personality differences, which by nature are not something we can manipulate. So we use non-experimental methods to look at those groups, but it might be within an experimental design. In reality, if a study is correct, there may be studies that support it and studies that don't. The differences we find in those studies put boundaries on the theory. So maybe X theory works for men, but not for women. When we review the studies that have been conducted, this is where we can find these differences. We also have more complicated relationships than just the relationship between two variables. Moderator variables are variables which basically says it depends. It may switch how variable X relates to Y. Does switch how the independent variable is related to the dependent variable. For example, suppose I find there is no relationship between gender and hiring rate. Women are just as likely to get hired as men. Now suppose I examine the type of job they are applying for as a moderator. When women apply for typically female jobs, they may have a higher hiring rate. But when applying for stereotypical masculine jobs, they may have a lower hiring rate. And then the opposite is true for men. It is important because the initial analyses show that there's no relationship. But yet when we add a moderator to look at the differences between men and women, we see that there is a difference and that there is a relationship between the independent and dependent variable. Another more complicated situation is mediating variables. In mediating variables, we're looking at a process. The effect of one thing works through another. So an independent variable affects the mediating variable, which then affects the dependent variable. For example, thoughts affect physical movement, but this is done through neuron activation. So we have a thought, our independent variable. There's an effect on the neurons, our mediating variable, which then affects arm movement or muscle movement, our dependent variable. In organizations, we have another situation that is more complicated. This is multi-level designs. We have nested groups within other groups. So for example, we have departments that are nested within organizations. We also have work groups that may be nested within departments. And if we look at an individual level, people have experiences throughout a day or a week, and those are nested within the person. In order to get to these, in order to understand the relationships and to see if there are differences in the different levels, do things work the same at one level as they do at another? We need to use multi-level designs. I want to talk a little bit about sampling. Who should participate in the research? We need to go back to our question and see what population are we interested in? What is our question that we have, and how should we sample from this population? Ideally, you want to study the population you're interested in. Sometimes we don't have access, or at least easy access, to that population. And we have others who are more convenient, such as students. If we believe the relationship should be the same in a convenience population, then we might choose to use it out of ease. But this is where reporting is extremely important. We need to tell the wider world what population was used and how participants were recruited. This allows the audience to critique and decide for themselves whether they feel it is the best test of the hypothesis, and to what extent it may generalize or have external validity. When we have questions about a population value, sampling is extremely important. We often talk about random sampling, in which everyone has an equal chance of being chosen to be in the study. Like I said, this is important when we're looking at population values. So what percentage works in jobs in which they use their hands? What percentage of the population has a second job? Relying on convenient samples will likely bias your estimates, but you don't always know how. And when you try to do random sampling and you offer people to be in a study, but not everyone agrees to participate, you start getting bias in those samples. When you're interested in relationships and causality, truly random sampling of the population may not be as important, unless there's some moderating variable that you may or may not know about. If you're interested in the relationship between satisfaction and turnover, this might be a relationship that exists in the population. But if it only exists for a portion of people, say second wage earners, it's going to be important who is in your sample.